Good afternoon to you. Mark Sudduth, HurricaneTrack.com here. It is Thursday, the 23rd of September, 2021. Time for the Hurricane Outlook and discussion. We have a lot to outlook and a lot to discuss today, so let's jump right in and take a look at what we've got out there. Of course, Sam is the big story, and we'll get to that in more detail here, but we have a few other areas to keep an eye on. None of those really posing any threat to land, so I'm not too concerned about anything else. Sam is really the headline here, and we even made a special graphic for it. I think Tim made this for us, one of our back-end artists. Sam, Tropical Storm Sam. We're going to be talking about this for at least a week, certainly longer than that, and it could be a problem. We'll have to look and see a few options here. We're going to go over that in pretty thorough detail today. This, though, the 5-day graphical tropical weather outlook. One important note as I mouse over the SAM icon. Look at where it's located, 10.9 north. Let's just round that up and call it 11 degrees north latitude. I want you to keep that number in mind and just kind of commit that to memory. 11 degrees north. All right, that's going to be very important, and that's a latitude point as to where it's located on the map. 11 north. Remember that, all right? Write it down somewhere. 11 north, okay? So now let's move along, and hopefully you've written it down or you committed it to memory. And let's look at the satellite animation this afternoon, courtesy of TropicalTidbits.com. First thing, there's this front that came down, bringing a big autumnal air mass to a good deal of the eastern half of the country, really. Drier air mass, a bit of cool air convection. I wouldn't call it cold air just yet, but that's the lateral or horizontal movement of air when you call it advection. Convection is vertical motion, just in case you were wondering. And this will knock down the sea surface temperatures just a little bit, removing a little bit more energy from the Gulf. But, make no mistake, this is still very open for business all through here for the rest of the hurricane season. And in fact, as we get into October, kind of skipping ahead a little bit here, I see a favorable pattern setting up for this part of the western Atlantic basin once we get really into October, after about the first week or so. We'll deal with that when we have to. First of all, we got to deal with this, and that is Sam out in the deep tropics. And remember, it is located, the center of circulation, when we say it, in this case, the center of circulation right about in there at about 11 degrees north latitude. And again, I think that's an important thing to note as we go forward. I'll explain why as we progress. So the visible satellite animation, courtesy of Weather Nerds, their website, weathernerds.org. Pretty well organized, good banding features, and then that little CDO, the central dense overcast with one overshooting convective top right there. Nice deep thunderstorm and some lightning in there, indicating a lot of instability, a lot of moisture. And Sam is on its way to strengthening. It'll become a hurricane as it moves off to the west and eventually the west-northwest with time. And that is a big key here. The motion of it, its heading, its bearing as we call it, and how much latitude, that 11 degrees north I was telling you about, how much latitude does this gain over the coming days versus how much longitude, how much more west does it get versus how much more north does it get as it progresses. And this is really going to start to matter as we get closer and closer to this getting into the vicinity of the islands, the Northeast Caribbean islands, that is, and what impacts may be expected there. There could be none. It could be well away by hundreds of miles, and some of the guidance does show that. Or it could be close enough, maybe even a direct impact. We'll have to wait and see. We don't know for sure. One thing that's interesting about Sam, it's moving along, it's going to kind of slow down. It's not just going to barrel through the deep tropics. It's a very different kind of a pattern out there. We've got all this traffic, if you will, kind of still going by to the north of where Sam is located. We can go back to the other satellite animation, and I can show you that. The remnants of Peter, this other system that's got outlooked in the tropical weather outlook, Rose and its remnants up here, Odette, whatever. Lots of other stuff going on to the north of Sam, so it's not a cut and dry pattern with a giant subtropical ridge sitting over the Atlantic, simply steering this west, barreling into the islands. That is not the setup that we have. Instead, it's more complex. Again, leftovers of Peter, whatever this little trough deal is in here, Rose and Odette and all that, it is complicated. So just keep that in mind. But again, the more westerly course this takes before it starts to turn, and it should start to gain some latitude, is going to matter, because if it's more south and then it starts to turn and it cuts across the islands like that versus up here, you don't need me to tell you that's a big difference there. And we don't know for sure how that's going to play out down the road. We'll have to wait and see. I will add, too, that this is not necessarily a case of the weaker it is, the more west it goes, because the steering patterns are really not the same. We're getting into the later part of September. There's all this other complicated stuff going on. And it's not necessarily one of these easy situations where if it's really intense and big in the atmosphere, it's going to go a certain way. There's no rules that you can apply to this that are going to stick, that we can absolutely bet everything on. This is going to be tricky over the next few days, and I have a lot to explain to you as we go forward. Now, one of the parameters here that we can bank on would be the increase in upper ocean heat content. Again, let's go back to the map. It's at 11 north roughly, and sitting out there at about, we'll just call it by this time 39 west. This is again from 11 a.m. So it's moved a little bit. So let's call it 39. Let's even round it up to 40 degrees west by 11 north. So it's roughly, let's use the color red so this will pop. The center and the overall circulation is located roughly right in here, right now. That's a good approximation. So it's in this marginal lower end category of upper ocean heat content. And as it treks along to the west and west-northwest, what's going to happen? Well, you can clearly see it'll get into higher and higher heat content values. No matter where it ends up over here, they're just going to go up and up and up the scale to an extent. The bottom line, this is definitely one of those situations where I can say, I am 100% sure this is going to become a hurricane, and 90% sure this becomes a major hurricane, and I think that would make the fourth major hurricane of the season if it does so. So, yeah, this is going to pile up a few ace points, that is for sure. That quantitative feature, a metric, if you will, that tells us the quality of the storms that we've had this year. Some of them, Peter, Rose, and others, Mindy earlier, I think it was, very short-lived. Odette, not a lot of energy output. Sort of these names that come and go real quick kind of deals. But Ida, Larry, and now Sam are really going to pile up some big accumulated cyclone energy points, which is a metric that scientists look at. That's a real important feature to understand the quality of what was out there. The fourth major hurricane probably coming up in the next several days with plenty of upper ocean heat content to work with, even if it ends up somewhere over here. And yes, I know we can all look at the models out to 10 days, and we'll do that in a moment ourselves. Bottom line is Sam's got plenty of fuel to take advantage of, and I think it'll do so. All right? There's a concept we need to start talking about. Trough split. Our graphics people put this together for me. I appreciate that. Trough split. What is that, and why is it important? Well, we'll talk about it, and hopefully I can explain it in a way that you can understand. So let's look at the modeling here. We're going to look at two of the global models, the GFS, and about midway up in the atmosphere, 500 millibars, or about, I don't know, what is it, 18 to 20,000 feet, something like that, if I remember correctly. So not the low levels, not the 5,000 foot level. You're used to me showing this level right here. Let me just pull it up real quick to remind you. That's what I'm used to doing. But we're going to go different this time and show you these upper dynamics. And that would be the 500 millibar heights. And that's what these reds and oranges are. Gives us an idea of the troughs and the ridges, the steering layer, or at least part of it. And the surface pressure, the mean sea level pressure of what we're looking at. And so there's Sam down there. If it would use a color that would pop better, how about white? So there's Sam in the model. There's the leftover of Peter. There's Rose sitting in there. There's the leftovers of Odette or whatever the heck that is. There's that little surface trough deal. All kinds of stuff. Like I said, and then there's this little system over here off the Iberian Peninsula, carving away the trough, or carving at the ridge with a trough out here in the eastern Atlantic. So it's not easy. This is not just all one big connected red area of high pressure stretched across the Atlantic that would send Sam due west into the Caribbean. It's not that easy. This is going to be complex. So let's move this out to day 5. All right, just scooch it on along, 48, 72, 96, and then finally 120. One of the things, and I got to give the props here to Dr. Cowan, Levi Cowan, this map is mouse overable. Is that a word? It is now. And I love that. We can put our little cursor and it tells you these lat long areas. Remember that 11 degrees north I was telling you about? Why was that important? Because in 5 days, according to the GFS, if I can get my mouse to stay still, there, that's a pretty good approximation. Sam only gains about 5 degrees latitude. In 120 hours, it's sitting from 11 now to 16 and about a quarter, we'll just call it 16 degrees, north in 5 days by 54 degrees west. So it's moving on at a basically west-northwest heading. I don't know, about 280, something like that on a compass bearing. I'm just approximating here. That's important because the longer it takes to gain latitude, the more south it is. Now, before you go, well, wow, Mark, that's pretty, you're a real genius to figure that out. That is important, though. And it only gains a little bit of latitude there in that 5-day time frame. So all of the models agree to that. And I can show you, we're not going to go over everything. We'll be here all day. But let's at least skip ahead to the euro and jump out to the same time frame. All right, 48, 72, 96, 120. Where is it? Same kind of thing. Actually, the euro is just a hair farther to the south. But you know what? Let's average them and just call it 16 degrees north latitude, and it's almost the same longitude, 54. That is remarkable agreement out to 5 days. That's a good thing. We can kind of embrace that. We want to be able to trust the science, trust the models here. If something's coming, we want to know it's coming, have faith in the guidance so we can get ready for it. That's different than, come on, bring it in, I'm ready for that hurricane. Yeah, some people, they enjoy a good hurricane, I guess. That's a whole other story. They don't like the death and the destruction, but hurricanes don't bother everybody the same way. That's also a fact. What we're looking at is just the pure meteorology here, the guidance set up here, the steering. And in 5 days, tremendous agreement between the GFS and the euro as to where Sam will be. So that's one important benchmark that we can sort of put a pin in and go with. So let's go back to the GFS, and we're at day 5. Let's move it out to day 7, 2 more days. At 168 hours, more to look at here, very important. Where is it located? So now the center of the low, roughly 21 degrees north by, we'll call it rounded up to 61 degrees west. So 21 by 61, and the euro at day 7, looking at that, is 19 and some change. So about a degree and a half farther south and a little bit more west, right, by a little bit. So the euro is just a tad southwest of where the GFS is. And we can just go back and forth between the panes, the tabs, and show you. Really easy to visualize there. Very important as well, that is a trough in the steering layer, the upper levels of the atmosphere, digging in to the northwest Atlantic here. That erodes that western part of the ridge. If this wasn't here, Sam would just come on right in and eventually maybe come up the coast or could go through Florida. I mean, the trough is what erodes that ridge away. But the orientation of the trough and what happens to that trough at day 5 are very different on the GFS and the euro. First of all, the GFS has less height rises over here. That's what this coloring is. There's red showing up on the euro, more of a height rise, and this trough kind of pinching off You see this is more southwest oriented, and whereas on the GFS, the trough is much more, well, it's less southwest oriented. Let's just put it that way. It's not pinching off as early, I guess, and as pronounced splitting as the GFS as the euro is. And that's that term, that trough split. This is extremely important in terms of what happens next. So the GFS, day 7, and then we go on to day 8. Right there, the trough pinches off, splits away, and that's what that means. The energy pinches off. Right here, it splits. Now the jet stream energy is up here. This energy is left behind. It is sitting out over the Northwest Atlantic, the Mid-Atlantic states, etc. It is able to capture SAM and kind of pinwheel it in to Nova Scotia, way out at around day 10. That's the end game there. And I don't mind showing you this because we're talking about it in terms of context, what to look for. See the trough, it comes in, there it is, it splits, leaves a piece behind, and that piece, I think, is a huge key. It's not everything, but that is a major clue in the evolution of what happens here with SAM going forward. All right? So what does the euro show? Well, the euro, there's day 7, day 8, it's already pinched off, and now we have a piece left behind down here over the southeast U.S. The ridge trying to build back over the top here, as we call it. There's also some pretty good ridging out here east of SAM. A little bit of a weakness through here, but SAM's not at that weakness yet, is it? No, it is not. It is southwest and down there in the southwest Atlantic. That's day 8. Day 9, 216 hours out. Pretty decent area of high pressure ridging here to SAM's east. Another area over the top, not as pronounced as it was. This upper level energy pinched off low pressure area and the mid levels, drifting southwest towards the Gulf Coast, and there is SAM. What happens after that at day 10? Unlike the GFS, but somewhat similar, SAM is much farther south and west. There's the GFS at day 10 right there. Look at the differences. SAM is way up in Nova Scotia. The upper level energy very far apart. That trough split is huge. The euro shows it with the remaining energy down along the Gulf Coast. GFS has that energy much farther to the north and east off the Mid-Atlantic, capturing SAM. That's huge. That's not everything, but that is freaking huge. But here's the other thing. It's 10 days away. What if those are not even there? What if that trough never even digs down that far? It tries and it just, it doesn't even do it. And there's just a lot more ridging. SAM keeps going more west. Maybe that trough is even deeper and just kind of stays more longitudinal there, dipping farther south, never really pinches off, if you will, or trough splits, and SAM gets picked up and whisked away even east of Bermuda. These are all possibilities that could happen. It's 10 days out. But I'm telling you, some of these other clues, how far north SAM gets over the next week, 5 days to a week, hugely important, especially to our friends down here in the islands. Yeah, absolutely. And then where it's oriented in relation to the southwest Atlantic as this trough split, if it happens. When it happens, if it gets caught and pivots in, it could pivot into the southeast. There's a lot of different possibilities here. And the main thing is we are literally talking about more than a week out in time. A week plus 3 days. The good thing, though, to remind you, at day 5, there is really solid agreement. That's good. Let's just look at this one day at a time. And every time we look at this each day, we'll look at the whole thing and just kind of look at these big puzzle pieces and see what makes sense, how the models are similar, where there are differences, and we'll take it from there. One interesting wild card that I speculate on is this, the anomalies map. All of this warm water up here, warm relative to the background state, the norm, the average. That's a lot of acreage out there of very warm water relative to the long-term average. I wonder if, and this might not even be a thing, I've always wondered this, if all that warm water relative to average since we're talking about 10 days out, if the models gradually kind of catch on, that there would be more ridging, because what does the warm water do? That leads to more generalized rising motion in the atmosphere, more ridging. The colder waters relative to average leads to more sinking air. Generally speaking, less rising motion is a better way to put it. So I just kind of wonder, does all of that warm water relative to average mean that the ridge just gets bigger and bigger every model cycle as the model is adjusting? I don't know. I don't know how they build these models. Do the models take into consideration, hey, guess what? GFS and Euro, whatever your engine is that develops all of this, cats or something outside my door. Luckily, one of them's not named Sam, but whatever. Does the model know that the water is anomalously warm? And in some cases, this really matters. Look at these in here and go down to the scale. 3 to 4 degrees Celsius. That's a lot. That's a lot above normal. That's a lot of extra heat in a huge area. It's not just a little island of additional warmth up there in the Northwest Atlantic. We can zoom in on this and make my point even more prominent here. That's a lot of real estate that's at significant warm anomaly levels here. So does that inflate the ridge even more? I don't know. We'll see. One way to know is in subsequent runs here, especially the true synoptic runs of 0Z and 12Z, do we just get more ridging? And I do think back to things in the past where the models adjusted. There was more ridge over time. Matthew is a great example in 2016. It looked like it was going to escape to the east of Florida by a pretty good margin, and that was just going to be that. But as time went on, there developed more ridging. There was just more ridging in the atmosphere, and the model had to adjust. It was the Euro that caught on first. I do remember that very distinctly. Irma in 2017, GFS was very insistent on taking it out, and it gradually had to adjust. We're seeing the GFS adjust a lot lately, more southwest each run. So when does that adjusting stop? And when do we start to shorten the window? There's all these questions, right? It's just almost an endless loop. But I do think that the warm water relative to average, and it's pretty darn warm relative to average up there, like I said, 3 to 4 degrees Celsius, that just might play a role in this as well. We shall see. And then there's other factors. A typhoon developing in the western Pacific. How much energy does that input to the atmosphere to create this bullwhip effect? Lots of moving parts. The bottom line, somewhere out in this vicinity in here is very likely to be a strong hurricane. And where it ends up, we'll have to wait and see, and we'll certainly do that together. All right, don't forget I'm on Twitter at Hurricane Track, YouTube and Facebook as well. It's all the Hurricane Track logo. Look for that. Look for me. Great to have you. We're supported, of course, by our crowdfunding people all around the world, over 1,000 strong. If you want to become a part of that community, Patreon, it's an app and a website, if you don't know what it is, that lets you crowdfund and literally direct how you want things to go. You get input, you get your say-so, you get to fund it. It's patreon.com/Hurricane Track. Join up anytime. Lots of benefits of doing so, access to a lot of different things that we put out there that the funding helps to go towards. All right? All right, so we'll be watching this very closely. And then, of course, once we get into October, that's a whole other can of worms. We'll get to that later. Lots of interesting things coming up for sure. Hey, look, as always, it's great to have you on your side of the screen. I appreciate it more than you will ever know. I really do. It's awesome to have you there listening and interacting on social media, etc. It certainly is wonderful. Have a great rest of your Thursday afternoon. As always, thanks for tuning in. I'm Mark Sudduth, HurricaneTrack.com. I'll be back with more for you tomorrow.